4, and I've already copied the chart to make my differential equation for my slope field. We're looking for a slope field here. So if you look, I took my y values, which are -1, 0, 1, 2, and stuck them over here for my y's, and I took 0 and 1 here and stuck it over here and here for my x's, and then I'm plugging all of those into this to find my slope at each place. So since this x is 0, I'm sticking 0 in for all of these coming down this way. And then over here, I'm sticking 1 in for all the 1s coming down this way. And then the y's, I'm sticking in for the y in the problem here. So 2 times 0 minus 2. That means that the ordered pair 0, 2. I have a slope of -2. So I want to put a slope of -2 right there. And then at 1, 2, I've got a slope of 2 times 1 minus 2, which is 0. So I need a horizontal, a very good horizontal. So I need a horizontal slope right there. And then for 0, 1, I got a -1 slope. So I'm going to make a -1 slope. Over here, I got 2 minus 1, which is a +1 slope. At 0, 0, I have a 0 slope right here. And at 1, 0, I get 2 times 1 minus 0, which is a 2 slope. So that slope would be like that. Although, now that I'm looking at it, they did not have dots there, so I actually don't need those 2 points. So I'm going to erase those two. These two we don't need because they didn't have the dots there. And then last, we need these bottom two. So this is a slope of 1. And this slope, 2 times 1 plus 1, is a slope of 3. So I did not need, I put them there first, but I did not need the ones on the x-axis. So that's my slope field. Okay, problem B says find the second derivative in terms of x and y, determine the concavity of all the solutions in quadrant 2. Give a reason for your answer. So the second derivative is going to be, and when I do the derivative of 2 with respect to 2x with respect to x, I get a 2. And then when I do the derivative of -y, remember I'm doing it with respect to x, so it's -1 dy dx. Well, I do not want to keep a dy dx in there, and I know up here that that equals 2x minus 1. So the second derivative is 2 minus 2x plus y, because I went ahead and distributed this negative sign to both of these numbers from up here. Okay, so that is my second derivative right there, 2 minus 2x plus y. Then for the second part of this equation, questioner wants to know what kind of concavity is in the second quadrant. Well, I have 2 minus 2x plus y. And then if I am thinking about the second quadrant, oops, let me erase all this. So the second quadrant, something you're supposed to know from Algebra 1, is x is negative and y is positive in the second quadrant. So what that means is, if I take 2 times a -2 times any negative x, and then this is a positive y no matter what, that gives me all positive numbers in the second quadrant. Everything's positive. So in quadrant 2, that means the second derivative of y is positive. So therefore, the answer is concave up in quadrant 2. And we would say because x is less than 0 and y is greater than 0 in quadrant 2, which makes d2y, which is second derivative of y, with respect to x greater than 0 for all those values. So that would be the answer for problem part B. So you have to find the second derivative as point, and then finding the concavity and explanation are another point. And part C says, let y be f of x be a particular solution, and they give me an ordered pair right here at 2, 3. Does f have a minimum or a maximum or neither at x equals 2? Well, we know that in order to have a min or a max, the first derivative, which is this 2x minus y, to find the critical numbers, that 2x minus y must be 0. So we take the point they gave us, 2, 3, and we plug that in. So we take 2 times 2 minus 3, which equals 1. So what that means is, since it doesn't equal 1, 2, 3 is not a critical number. So that means the answer would be neither. And the reason would be, or we would just say at x equals 2, and that's because 2, 3 is not a critical number. So that's part C. So those are pretty easy. Part D is by far the hardest question we will have had so far in this whole thing. So part D says find the value of the constants m and b for which y equals mx plus b is a solution to the differential equation. So y equals mx plus b, and we want to find the derivative of this. So if we do the derivative of y, it's dy dx, and the derivative of mx plus b is just m, because b is a constant, and I hope we all know that the derivative of b, or any constant, is nothing, so dy dx equals m. So if you look up here, here's another dy dx. So what that means is that 2x minus y has to equal m, because this dy dx and that dy dx up there have to be equal. Now this is where it gets crazy hard. This is one of those problems I wouldn't expect very many people to get right. We have 3 variables over here. Over here's 3 variables. So the first thing I'm going to do is I'm going to plug this in to get rid of some variables in for that y. So when I plug that in, I get 2x minus mx plus b equals m. Okay, then I'm going to distribute my negative sign, and I'm going to get that 2x minus mx minus b equals m. So if you look here and here, we have constants, or I mean, a common factor of x. So I'm going to factor that x out and get 2 minus m times x minus b is also equal to m. Okay, so this is going to be a pretty hard problem. So what I'm going to do now is I'm going to leave the left side the same, and I'm going to write the right side to look like it is also, so that's still 2 minus m times x, and minus b, that is in slope-intercept form, because we think a 2 minus m is the slope of that minus b. And then I can put this side over here in the same form by making a 0x plus m. So these two things I want to be equal. So what that means is 2 minus m, which is the slope on the left side, has to equal that 0, or the slope on the right side. And then we want the 2 constant parts to also be equal. So that means that negative b has to equal the m part. This m part over here and that negative b there have to be equal. So if we take this 2 minus m equals 0 and add the m over to the other side, that means that m equals 2. And then we can plug that 2 for that m over here in for this m and get that b has to equal -2. And there's your m and b to make those equal. That is by far the hardest problem. And again, I would not expect very many of you to get that right. And it's okay, because you don't have to be perfect to get a 5 on this thing. So that's the end of this problem.